my math friends. Today we're going to be working on proving some trig identities. I'm looking at the worksheet that's titled Trigonometric Identities MCR3U. You can grab that worksheet, pause the video if you need to. So we're going to start here with number 3. We have sine squared theta minus cosine squared theta equals 1 minus 2 cosine squared theta. What I like to do when I prove a trig identity or verify a trig identity is I make a wall. And I'm going to work with one side of the equation and try to get it to look like the other side. So this is not like solving. We don't go back and forth across the wall. We try to pick the more difficult side to work with here and try to get one side to look like the other. So I'm going to choose to start on the left here. And sometimes that's a judgment call, but that's what I'm going to do here. So when I look at sine squared theta minus cosine squared theta, one of the things I think about is that Pythagorean identity, except for that Pythagorean identity is sine squared plus cosine squared theta equals 1. So I know I can't use that exactly the way that it's written, but I know if I rearrange it, I know that sine squared theta is just the same as saying 1 minus cosine squared theta. So I can change this sine squared theta to be 1 minus cosine squared theta, and now I still have this. I'm going to bring that down. So I have 1 minus cosine squared theta minus cosine squared theta, and that's going to give me 1 minus 2 cosine squared theta, which is exactly the same as the other side. And when it's done, we can call it done. Sometimes you might hear the math term QED. That means as it is done. If we look at number 8, we have tangent squared theta divided by sine squared theta minus 1 equals the tangent squared theta. So again, I'm going to draw my wall. I'm going to start to look at the more difficult side, which is the side on the left. And I'm going to start to simplify this. So there's a lot of different ways to do this. Not everybody is going to do it the same way, but what I'm going to do is try to see if I can change this tangent into sines and cosines. So I know that tangent squared theta is the equivalent of sine squared theta over cosine squared theta. So I'm going to start with that. And all that is divided by sine squared theta. And then we have our minus 1 over here. And I want to think about, when I divide fraction by something, I keep the numerator. So sine squared theta over cosine squared theta, that's my numerator up here. And I'm going to change the operation from divide to multiply, and I'm going to multiply by the reciprocal of the denominator. So that is 1 over sine squared theta. So now I can cancel those terms out, and I'm left with 1 over cosine squared theta minus 1. And I know that 1 over cosine squared theta minus 1 over cosine squared is the same as secant squared theta. And this is one of those Pythagorean identities. So if you look at your identity sheet, the secant squared theta is equal to 1 plus tangent theta. So I know that tangent theta is the same as secant squared theta minus 1. So this becomes tangent squared theta and tangent squared theta. So we are set with that. The last problem that I'm going to try here with you today is number 13. So 13 is a little bit harder here, but we can do this. So we have our tangent squared theta minus sine squared theta equals tangent squared theta times sine squared theta. I'm going to work with the side on the left. And again, sometimes it's a judgment call. Sometimes if you're working on one side and you don't get anywhere, you can go to the other side and work on that and maybe work your way to the middle. But we don't cross over the wall. In general, we try to keep to one side. So tangent squared, sine squared theta over cosine squared theta minus sine squared theta. Now I always want to keep in mind what my end goal is. My end goal is to have tangent squared theta times sine squared theta. Okay, so I have two things here. I want to try to see if I can combine them to one term. But in order to do that, I need to have a common denominator. So my common denominator here is cosine squared theta. So what I'm going to do is multiply the numerator and the denominator here by cosine squared theta. And that's just so I can combine these two terms into one. So we have sine squared theta over cosine squared theta minus sine squared theta cosine squared theta over cosine squared theta. Now that I have my common denominator, I can put these into one fraction. So my numerator is going to be sine squared theta minus sine squared theta cosine squared theta. So I want to stop for a minute and just take a look at what I still need. I need to get tangent squared times sine squared theta. So I have a little bit of work to do. But one of the things I notice here is that sine squared theta is in both of these terms. I can factor that out. And if I do, I'm going to get sine squared theta times 1 minus cosine squared theta over cosine squared theta. Notice how I kind of wrote this over to the left here. What do we know about sine squared theta divided by cosine squared theta? Hopefully you remember that that is equivalent to tangent squared theta, and now we have our 1 minus cosine squared theta. Looking at this, this is kind of like your Pythagorean identity, sine squared theta plus cosine squared theta equals 1. If I rearrange this a little bit, sine squared theta equals 1 minus cosine squared theta. So I'm going to take this now and sub it in over here to get tangent squared theta times sine squared theta. And now the left side is exactly equal to the right side. And we are done. Thanks, guys. Have a great day.